Welcome to the Explainer. Look, if you have ever felt that stomach-dropping anxiety of a Friday afternoon deployment, or if you've just struggled with clunky, slow, or downright fragile deployment processes, this Explainer is absolutely for you. Today, we are deconstructing a highly efficient production-grade MLOps pipeline. We're going to break down the exact architecture decisions that make zero downtime deployments with enterprise-grade reliability possible. We're stripping away all the pain to reveal a flawless, automated journey from a developer's laptop directly to a live cloud environment. Let's get right into it.
Okay, let's dive into this. 72 seconds, that is the total lead time from pushing a line of code to having it live right there in production. We are talking about a fully automated system that tests, builds, and deploys machine learning models with zero downtime in just over a single minute. I mean, it's a mind-blowing metric, right? It completely redefines what we should actually expect from deployment speed in modern development environments.
But you know what? This speed isn't even the best part. For this entire production-ready setup running in the cloud, the estimated operational cost is just $40 a month. That's it. It proves a massive point for us. Enterprise-grade reliability, automated rollbacks, seamless scaling, they do not have to break the bank. You really don't need some massive, bloated budget to have top-tier DevOps infrastructure supporting your machine learning models.
Which brings us to a really massive question. How do you deploy machine learning models with zero downtime in just 72 seconds, completely without Kubernetes? Throughout the rest of this explainer, we're going to basically reverse engineer the architectural decisions that make this miracle possible. We'll see exactly how stripping away unnecessary complexity and choosing the exact right managed services leads to these blazing fast, incredibly reliable results.
Let's start with the speed. If we break down the continuous integration, or CI, pipeline efficiency, the entire process takes a mere 40 to 55 seconds. Checkout is 2 to 3 seconds. Python setup, just 8 to 12 seconds. And this speed isn't an accident. By strategically caching pit packages, which is essentially like keeping your standard ingredients right there on the kitchen counter instead of driving to the grocery store every single time you want to cook, that setup step is 60% faster than standard setups. Add in parallel test execution and cache Docker builds taking just 15 to 20 seconds, and you've got a heavily optimized, totally frictionless pathway right to the cloud registry.
Now, all of this speed is driven by one very specific philosophy, built for teams who want DevOps reliability without the DevOps complexity. It is fundamentally about getting all the benefits of a robust, self-healing system, but without needing a dedicated team of infrastructure engineers fueled by energy drinks at 3 a.m. just to keep the servers running. So let's look at the specific architecture decisions that honor this exact philosophy. And this brilliantly illustrates the biggest architectural decision here, choosing AWS ECS Fargate over Kubernetes. See, architecturally, Kubernetes forces you to manage the control plane and the underlying nodes. ECS Fargate eliminates that entirely. It operates strictly at the task level, meaning you only ever have to think about the container itself. Setup complexity? Fargate is remarkably simple because it's managed for you, whereas Kubernetes is notoriously complex to configure and maintain. Scaling is handled automatically by Fargate, and crucially, you only pay per second for exactly what you use. For small to medium teams, actively deciding against Kubernetes eliminates massive operational overhead. Just to be absolutely clear on the architecture here, AWS ECS Fargate is a serverless compute engine for containers. You literally never provision a server. For machine learning specifically, this architecture is a total game changer. Machine learning traffic can be highly unpredictable and extremely resource intensive, right? Well, Fargate allows you to spin up the exact CPU and memory needed for a specific inference task, execute it, and then scale back down automatically. You inherently get zero downtime rolling updates and automatic recovery on failures, all seamlessly managed in the background.
Now, what's really interesting about this slide is how we actually get these containers to deploy so fast. The secret is multi-stage Docker builds. Think of it like building a car in a factory, but only shipping the finished, polished car to the customer, not shipping the massive robotic arms and tools that built it. By stripping out all the heavy builder tools and compilers from the final production image, the image size plummets from a bloated 800 megabytes down to just 19.8. Not only does this massive reduction speed up the build time to a mere 15 seconds, but it heavily reduces the attack surface, significantly increasing your overall security posture. When we move to the application layer, the framework of choice is FastAPI. It provides a staggering 3x performance multiplier over older frameworks like Flask or Django. But it's not just about raw speed. FastAPI was chosen for its native async support, which is absolutely crucial for handling concurrent machine learning API requests efficiently. But even more importantly, it includes built-in pydantic type safety. Think of Pydantic like a strict bouncer at an exclusive club. It ensures that malformed or dangerous data is firmly rejected before it ever reaches your delicate machine learning model.
So we have incredible speed and efficiency. But what about safety? Every single code commit must survive 3 strict security layers just to reach production. Step 1 is Docker container hardening, utilizing those multi-stage builds we just discussed to keep the image lean and secure. Step 2 secures the supply chain right from the repository via GitHub actions. And Step 3 relies on that FastAPI bouncer we just talked about to actively defend against bad inputs. This proves definitively that moving at 72 seconds does not mean you are sacrificing enterprise-grade security. No way.
This speed in security is backed by absolute reliability. Every single code path is validated before a deployment ever triggers. This includes liveness probes, which, if you aren't familiar, are basically automated pings constantly asking your server, "Hey, are you awake?" every few seconds. If a bad deployment breaks a server, the probe fails, and Fargate automatically rolls back the update, 0 downtime. From these startup probes to happy path model inference and edge cases, this compact suite boasts a perfect 100% pass rate, ensuring the auto rollback and self-healing features always have reliable triggers.
So the crucial point is this. By making deliberate, lean architectural decisions, leveraging AWS ECS Fargate instead of Kubernetes, using multi-stage Docker builds, and implementing FastAPI, this pipeline achieves 0 downtime rolling updates, automated quality testing, a secured supply chain, and self-healing on failures. And because it relies on standardized containers, it even leaves you with multi-cloud-ready templates. All these simple managed architectural choices culminate into a flawlessly reliable, fully automated system.
Which leaves us with a very compelling question to close out our explainer today. Is your massive Kubernetes cluster actually slowing you down? Look, it is so easy to default to the most complex, industry-heavy tools just because they're popular, or, let's be honest, they look impressive on a resume. But as we've seen today, sometimes the absolute fastest, most reliable, and cost-effective path to production is simply cutting the bloat and choosing the right managed architecture. I hope this deep dive into a 72-second deployment pipeline inspires you to explore leaner, smarter alternatives for your own tech stack. Thank you so much for joining me today on The Explainer. Keep learning, keep building, and we'll see you next time.